Um, the next speaker we have uh, um, Shuvam and Naveen from Wells Fargo. They're going to be coming and discussing scaling AI at Wells Fargo. They both are technology and business leaders from Wells Fargo focused on platform engineering and strategy on AI. So welcome.
Thank you so much.
Yeah, thank you.
All right. Hello, everyone. Good afternoon. I know it's about 4 p.m. You, I'm sure, had a good lunch. So I hope this would be an interesting conversation. So me and my colleague Naveen will take you through. So for a quick introduction, my name is Shuvam Sengupta. I am a vice president of AI/ML platforms and engineering at Wells Fargo, and I'm accompanied by Naveen. Naveen, please.
Hi, I'm Naveen. I head the machine learning development for the CO functions within Wells Fargo, primarily dealing with structured machine learning. Thank you.
Thank you, Naveen. So our topic is going to be a little bit of a story, all right? All day long, you have heard about fantastic use cases that various organizations in banking, in telecom, in insurance, how they've applied AI in various use cases. So today, we will talk about the story of how a 170-year-old bank with a lot of legacy systems and a lot of, I would say, legacy processes are adopting AI, making AI at its core. And not just at a strategic level, we will take you to the tactical and the ground level of how some of these things are taking place and how we are shifting the ground from being a traditional decision-making bank to a data and AI-driven decision-making bank. So where did we start? I mean, roughly about even 4 or 5 years ago, our majority of workloads of, if you call AI, if you call ML, if you call data science or statistical modeling, was mainly around the old school marketing and risk models. Majority of them were linear models and static models, which of course needed a lot of time to build, to deploy, and to maintain. Cut to today, having AI at its core, a lot of our business areas are incorporating AI in their decision making. This revolves around digital transformation. Think about chatbots. This revolves around operations. Think about large-scale payments operations, or HR, or even contact centers, or even think about customer experience like recommendation engines, or capital markets, where millions and millions of trades happen at every minute and every second. All right, and this scale can only be efficiently managed if you have AI-driven decision making at its core. So I'll take you a quick example. Many of you may have heard about Fargo, which is the conversational AI chatbot that Wells Fargo launched like last year. It is a really, really large-scale project within Wells Fargo where technology teams, data science teams, many vendor solutions have come together to make it happen. Some of the other strategic shifts we have had as an organization to make this happen is, I would say, not just making the businesses believe that AI can really make a difference in how their businesses is run, but also as the data science, ML engineers and the ML practitioners community, we are driving a significant shift in mindset about how to be more agile, fast in terms of developing and deploying AI in each of these businesses. What does that mean? That would mean, for example, whenever you're developing an AI, how can you make it a lot of rapid experimentation through the process, all right, and get those experimentations and the results past your business, almost have your businesses partner with you in a weekly basis to see how AI, the results are coming out and how the bottom line or the top line is being impacted, and quickly being able to incorporate those learnings back into the development, all right, and probably run some of those models in what we call a bit of a soft launch before it goes into a hardcore production environment where it gets consumed by the business systems. That could be one example. The other example would be many of the model pipelines, be it your data pipelines or the model inferencing pipelines, how can you automate that, all right? And there are various ways to do it, efficient CI/CDs or creating feature stores that you can reuse for multiple different types of models. All of that are happening today at a much faster pace and much more efficiently than it used to be even a few years ago. Coming to a slightly different area, all right. Over the last couple of years or so, Wells Fargo's NLP workloads has been increasing at a very rapid pace. A lot of our businesses are incorporating natural language process driven decision making in maybe customer experience, in risk mitigation, and various other business problems. I won't go into the detail right now because that's what Naveen, my colleague, will do, but it will be in similar lines to what many of you have already seen in other use cases and other presentations today. And the last but not the least, and the much more recent development is, lately we are investing quite a lot and significantly thinking about how we incorporate large language models, pre-trained models into a lot of this decision making, particularly into the NLP workload. What does that mean? Our NLP driven processes or the NLP models not only will be more accurate, more faster, but also will be able to unearth a lot of new type of use cases. For example, many of existing use cases are about entity extractions, classifications, but we are not yet doing a lot of generations, text generations or summarization kind of use cases, all right? So think about use cases like some asset evaluator is writing a report on the valuation of an asset. It's a 5-page document, all right? AI can make it into a quick 2-paragraph where somebody, the underwriter, looks at the summary and takes a decision, all right? So all these things will be the new generation or the future looking solutions that the large language models will implement for us. And we are looking at various types of vendor solutions as well as internal solutions to make this happen, and H2O has been a key partner, and we look forward to having H2O as a key partner in this journey. All right, so that was about, let's say, the use cases, the mindset shift, and also about maybe some of the different types of areas that we apply AI. The backbone, or where all this AI happens, is where the platforms are, and this is where you see our platform strategy. So right now, I would say we as an organization has been a little late to adopt cloud, but we are definitely going there. So right now we are still on on-prem. However, we have a very high focus on buying the best vendor solutions before building anything on-prem. Our base infrastructure is still on-prem, but like H2O, we have a plethora of niche vendor solutions to solve certain problems or do certain jobs into the entire AI pipeline. For example, you can think of data labeling, programmatic data labeling. You can think of feature stores. You can think of automatic model inferencing, all right? A lot of these areas we lean on specialized vendor products, and we wish to continue to look into it that way. Our future is about going to the cloud. It would be a mix of public and private cloud environments and on-prem environments, because being a bank, we don't envision completely moving on to a cloud environment. Some of our data, etc., would be too private, all right, to move on a cloud environment. So we'll probably have a mixed and hybrid environment, but the philosophy remains, all right. Cloud will, of course, enable us becoming much more agile and scaled, but we will not only use the out-of-the-box solutions of the cloud providers in AI, but we'll also keep on leaning onto some of the best-in-class vendor solutions with specific niche focus areas. All right, so that was about, let's say, the strategic footprint, where we are and where we want to be. Now, let's talk about on the ground how it happens. What are some of the tactical levers that make this change possible? And I'll give you some of the real life challenges we face. So again, being in a banking environment, a regulated environment with legacy infrastructure, we have to live with the truth that our data is extremely federated. It's huge data. We are one of the top 5 banks in the US, but it's extremely federated. The different business units sometimes have their own data environments, and their own controls around the data. So it's very difficult to get all of that data into one single place to be able to do AI at scale, all right. We probably, for the near term, have to live with that. How do we, overcome this problem is we make sure that there are data platforms that help searching that data very efficient, all right. So the metadata, there are enterprise-wide programs that is making the metadata to be extremely strong, searchable. Anybody can go and look into what kind of data is there with some samples, without even needing to get to access to that entire database, all right. Some of the other ways to do it is we are investing significantly to have very robust ingestion tools, all right, that helps us ingest those kind of data from any and every type of databases into our AI ML environments, all right. So that is, let's say, the first enabler I can think of. The second one, I think I already touched upon, is about being agile in terms of doing very rapid experimentations and very rapid combinatorial, experiments on the models, and being able to quickly show that to the business and get their inputs. I'm not going to go into that detail much more here. The third one, mainly about our unstructured data and NLP workloads, is about being able to create ground truth and labeling at scale and very fast. So I think some of our colleagues from other use cases that you heard touched upon that. It's a very, very time consuming and costly process for businesses to, invest that manpower or SMEs to label tons and tons of data, all right. And that becomes a barrier towards adoption of AI for some of the new businesses that are still not there, all right. And this is where these kind of solutions you heard about, I think the labeling tool that Ching was talking about, these kind of tools we are putting in and making it available to the large scale businesses so that the labeling becomes easier, quicker, cheaper. Then real time. Today it's an absolute necessity for any businesses to support real time models, all right. Again, taking those examples of real time fraud prevention, or taking the examples of the real time trades that are happening, all right. Models have to be scored real time, decisions have to be taken real time. Without that, we are not going to be successful in this new world. And what we are doing in this space, we are not only allowing for real time scoring, but we are also building capabilities to create features real time and get them updated in our feature stores in real time as well. All that said and done, models drive value when they are put into production, all right, when businesses can consume that. Again, being in a legacy environment, separated and siloed environments has their own challenges. For example, different models, there should be different consumption patterns that we have to support, all right. So there can be batch consumption that certain businesses need, real time or pub/sub based consumption certain others need, and even there are cases where legacy systems are so old school that even a Python object or a Pickle object cannot be consumed by them, all right. So there we have to be really innovative in terms of how these models can be consumed by the endpoint systems. There can be other environments where data privacy is such a big concern that model scoring cannot happen on an outside environment or in an AI environment which is not a part of the business data environment. So there you have to be really creative in how you can score the model in memory so that your data is not really coming out of the data environment. The model gets scored and the scoring output gets pushed back into the original data environment without anything coming out of it. So these are just some examples. I can go on and on probably about another 10 minutes on enablers, but hope you got the point. So at this point, I'll hand it over to Naveen.
All right, thanks, Shuvam. So I'll try to expand a bit as much as my sort of regulated industry allows me to get into these use cases to help you understand why H2O is so important to us and what value is it really driving for us. Let's start with the bottom of the slide and then make our way towards the top, right? We've heard from CBA, we've heard from SDFC. A lot of the use cases might sound similar, so I'll try to keep it as distinct as possible. But let's pick a very common area for any large organization, right? Let's take operations. What operations means to a bank is handling large volumes of payments, very erratic patterns of payments. Think of A minute in a bank could mean literally no transactions, zero value being transacted, to hundreds of thousands of transactions and billions of dollars of being transactions done in a single minute. So the level of veracity of the data, the level of uncertainty that's associated with it is just too huge. Having an ability for the bank to preempt this kind of a pattern, to understand the method to this madness, is very important. Two ways. One, it helps sort of plan out the operations a lot better. And second, and more importantly, it helps to ensure if there is a stress event that's happening in the system, whether it leads to a financial ramification, whether it leads to a operational issue, or it leads to an experiential problem, it's very important for the bank to preempt that as early as possible, right? Payments, what I talked about, applies the same concept to contact centers. You can apply the same concept to workflows planning. You can apply a similar concept to workflow plannings, right? Loans that are being generated, how do you process them in time? How do you anticipate what kind of demand will come in for the agents to act upon, and so on. All of this fits very clearly to the forecasting solutions that we deliver, right? Very critical tool for all of us in terms of both understanding and preempting the accurate estimates of these kinds of volumes, as well as alerting the process owners and the agents in time whenever something off is happening in any of these areas. Coming to the next piece, right? Risk mitigation, again, I think a lot of use cases touched upon that aspect. Just to extend to Guru Prasad from HDFC, right? Maker checker process involves looking at check processing. Very important aspect within that is understanding where the fraud really is happening when a check is being asked for processing. Is it within the check leaf? Is something about the check that is being forged or fraudulent? Or is it about the person who's signing that check, who tries to own that check? Is it the signature, the handwriting? Is it the way that particular check is designed? All of those pieces require a combination of natural language processing as well as computer vision, right? So very distinct use case than what we talked about in operations. Similarly, we try to understand how valuation of assets is important, whether it's for commercial banking, whether it's for corporate and investment banking, whether it is for wealth and investment banking. Different areas have different assets and they have to be evaluated real time over and over again, right? That, along with managing the data that Wells Fargo owns, there is a lot of data which requires frequent metadata classification. New sources keep coming up. How do you identify and sort of predict what kind of classes these data sets belong to? All of these areas go into the traditional classification and regression problems, right? And coming into the digital and online experience, so Wells Fargo is primarily a player on the digital experience side fairly in the last 7 to 8 years. We've built in a lot of experiences around apps, around web pages and so on, which help the consumer become more better and in control of the kind of operations that they want to perform. So that brings in a whole new set of challenges and problems. It deals with identity management, identifying if the right user online is accessing the right services that are being associated with that particular customer. It involves understanding whether there are specific digital friction points. What are their root causes? Are there really frictional points for a subset of customers, or is that a larger process problem within the ecosystem? All of that would fall into the unsupervised solutions that we have to build, primarily leveraging anomaly detection techniques and so on. And finally, looking at customer experience. Chatbots, Shuvam already touched upon a bit. Product recommendations, and this could be products that Wells Fargo is providing to customers for use in the banking sphere, as well as it could be services from a digital perspective. Let's say you use Wells Fargo's digital wallet. Is there another service that I can recommend to you that allows you to have a more holistic experience with the bank? All of those things come under the recommendation engine of solutions and family. So what I'm trying to get to is there is a large plethora of use cases that a bank has to deal with. The AI community within the bank has to work with a stack of solutions, and it doesn't really fit into one particular box. How H2O helps us in that segment is it becomes a one-stop shop with respect to an access to a very large set of libraries that are maintained in a single ecosystem, rather than having to go to multiple packet sources and maintaining them individually. What it also helps us with is access to a large range of algorithms. It helps us with transformers that I can apply to the target as well as to my feature space, and I can really start to use driverless AI to combine all of these things together and understand what's working well for me and what's not. That is where AutoML comes into the picture, right? All of this, the best part of it is I don't have to use the UI, or I don't have to use the no-code interface. I can actually use the Python clients and thereby integrate everything that I just talked about in my modeling and data pipelines. That helps every data scientist in the AI community at Wells to scale their experiments faster, to ensure what works for them stays, what doesn't work for them, they clean it out and replace it with their original custom codes. That customization, along with the ability to set up these experiments fast, is what helps us drive a fast and agile model experimentation environment. Last thing to touch upon on this slide would be, how does it help the business really? Everything that I just talked about is entirely my benefit. But what happens is, because the UI interface is always available, whether I use the Python client or not, I can always take that UI interface to the business stakeholder and try to help it understand what kind of models are coming along, what kind of performances are they delivering. I can even get into the depth of explaining a particular prediction, explaining a particular model. It can happen locally, it can happen globally. It helps the business understand what the model is about. It helps the business give valuable feedback in terms of what do I really need to change in the model, what do I need to change in the feature space. And then we go back to the drawing board. So the redevelopment process becomes a lot more collaborative than transactional. Moving on to the next slide, Shuvam. So this is something that's very core to the Wells Fargo AI community. I just talked about how H2O helps, but we'll touch upon the features that are most valuable to us. Some of them I covered briefly in the previous slide. Rapid experimentation allowed through the AutoML, auto feature engineering, transformations, as well as experimental setups through the use of very, very easy to understand and apply intuitive parameters, so to speak. But coming into some of the more nuanced approaches, wherein explainability is an aspect. As a bank, it's very important for us to explain any and every model, whether it's right or wrong, whether it's simple or complex, doesn't matter. But it's important for us to explain why a model is giving the kind of result that it is giving. And so H2O, with its range of explainability techniques, starting very simple from sensitivity analysis to going to SHAPs and LIMEs, locos, and so on, helps us look at the model in various different lenses, understand its limitations, understand if it has any sorts of biases, how do we correct from them, and where do we correct for them most importantly. So that's an important aspect that is very relevant for any tool that we end up using, and H2O fits that checkbox very well. The next piece that I talk about is the model governance, right? And the reason model governance is important is that, given, again, it's a regulated industry, everything that we do requires a process, requires a documentation of it. Autodoc and its capability to be highly customizable and its capability to be provided on every experiment run helps us to fasten our documentation processes, because we can understand why H2O chose the kind of models that it chose, why H2O ended up choosing the kind of feature space that it finally evolved to and reached. So that's a very important aspect. And finally, custom recipes. This is just to ensure what H2O provides in stock is not the end story of any modeling experiment. It will require us to change loss functions. It will require us to change features that H2O may not have thought of, and we want it to be supplied through an external code. So custom recipes around the model training, around the feature development, and around explainability helps us make it a more robust and expansive tool, thereby allowing us to experiment on further use cases, not just stick to that particular use case, something that the CBA speaker also pointed out. So I'll pass it on to Shuvam for deployment pieces. And
Thank you. So I think this deployment point is another important point, but I think I've touched on this before. So given many of our consuming systems being modern, while others being not so modern, H2O has tremendously helped in having our data science processes or AI ML processes being flexible about it. All right, there are Mojo objects and Python objects which are common across the place, but they also supply us with Java and C++ model objects to be integrated with consuming systems which are not that modern to even accept a Python-based model object. All right, so a small example, but really goes a long way. However, coming to, apart from what we discussed about, what we are also exploring is H2O Wave. So we have already talked about, we work very closely with our business to sort of show them what is the, how the models are looking like, how the results are looking like, how is it impacting their individual business processes. We believe that Wave is a fantastic tool and gives us that opportunity to quickly create apps on the fly and show it. A lot of it is real time, which I already talked about. We have many real time use cases as well. Then we talked about, model inferencing is actually a very important area for us. We are looking into H2O MLOps as a product, whether that would be a good addition in our portfolio or not. And last but not the least, I touched upon large language models being a key focus area, all right. So understand that being in the banking space, using large language models will have its nuance, all right. For example, we will be asked whether the large language models have the right, the risk and compliance checks before they are implemented. Number two, whether we have the capability to deploy large language models in our systems, all right. So we are exploring products like Hydrogen Torch in that space, and just today I figured out there is another product called LLM Studio, which gives you the opportunity that you develop your own or fine-tune your own large language models on top of the foundational models, which is again something that's going to be very important for banks, because we will be asked, getting a completely pre-trained out of the, out of the box model, what sort of data it has been trained on, we don't know. So how you can train your own models, or at least fine-tune your own models on your own data, so that we are more comfortable that this fits our own purpose and it is risk compliant. All right, what's the target state? In the target state, I talked about in one of our earlier slides that we are moving on to cloud, all right. However, we will continue having some of our workloads on-prem, and even within cloud, there will be multiple cloud providers that we'll work on, all right. So the vendor solutions that we would continue to prefer working on, working with, would be those that provide us that flexibility to be on-prem as well as on any of the cloud environments. So they have to be cloud agnostic, but they also have to be cloud ready. And I believe H2O will continue to be a fantastic partner in that target state, and we look forward towards that partnership. Thank you.
Thank you.